What's up, guys? We are here at the Cooler Master plant where they manufacture several of their keyboards. We're going to take a look at the NK850, the SK line, which is brand new and just coming off today, as well as a couple different mice. We're going to take a look at how injection molding works for keycaps, some laser etching, and a couple other processes. I don't even know what they are yet, but we got to go inside and take a look at what this entire line does right after the intro. We started off our journey towards RGB Town by stopping in at the R&D center of the building. Here, teams of engineers concept, design, and hand assemble prototypes of new or upcoming products. Everything that comes out of this room is built in a CAD program and manually soldered together, and products usually go through between 4 and 10 revisions before they even make it out of here alive. The design, testing, and revisions phase takes anywhere between 6 months to a full year, depending on how complex a new keyboard or mouse might be. Here you can see a bare keyboard PCB with a trace diagram on the screen in front of the engineer to help with construction. Let's assume the keyboard that dude was playing around with actually becomes a real product. How and where does production start on something like that? Well, believe it or not, it starts with the keycaps. These are giant, mostly automated injection molding machines. Since many keycaps are slightly different heights or widths, each one requires its own mold. The mold is mounted to the machine and a transporter arm frees the molded plastic once the injection process is completed. Each batch of keycaps comes out of the machine connected to each other by small pieces of plastic that needs to be manually broken apart by a technician. The keycaps are then mounted to a frame and stacked on trays. The stack of trays is then moved over to the production line where additional prep work is required before they can be pressed onto your favorite Cherry MX stems. One of the things that has to be done to the caps is laser etching of the letters, numbers, symbols, and anything else that might appear on your keyboard. This might have been the coolest thing I saw while we were in China, as the etching machine is ultra precise and all you see is little flashes of light dancing across the black keys, with the end result being the letter Q or the word shift. Cooler Master was even awesome enough to take my logo and etch it onto a function key, something that they later gave me to take home as a souvenir. While we were watching, they actually made probably 4 or 5 of these, and each one of them looked exactly the same, with even the small details like the power button symbol coming out perfectly. The keycap adventure, however, is not even close to being completed. Because the laser etching process is actually burning off a layer of the injected plastic, if you were to feel these keycaps right afterwards, you'd be able to notice an indentation where the letters were. To rectify this, the keys need to go through a process of cleaning and resin coating. The resin acts as a UV resistant sealant, as well as filling in the small gaps left by the laser. It's at this stage of the process that keys that aren't receiving the laser etching treatment also receive their finish. They are painted by a large rotating machine with the paint color calibrated every 2 hours for uniformity. Keys that aren't being etched will usually receive a screen printing or adhesive in order to apply the letters. Workers check every keycap that comes through the machine for color and paint thickness to ensure there are no defects. It's in this room that some of the keyboard top plates also receive their markings. This is a screen printing line where technicians apply small lettering to the plastic housing, and then the pieces are dried thoroughly. When they come out the other side of the dryer, they are inspected and then packaged to head off to the assembly line. However, before we go there, there is just one more thing that needs to be done, and that's the installation of the switches to the PCB. This is a completely automated process with a large drum feeding the switches into a machine that presses them down into place. We're finally ready to start putting things together, and on this tour we got to see 2 different assembly processes. The first was the new SK621, a wireless, 10-keyless, low-profile RGB keyboard that we saw first at CES. After the batteries are secured in place and the frame screwed down, a technician attaches the power cables to the pre-assembled PCB and switch top plate. The keyboard lighting up at this point is a good sign that all systems are go and that the batteries work and no wiring mistakes have been made. To make sure though, the infant product goes through its first quality check to see if everything is recognized. After that, it's off to the screw station, which sounds dirty, I'm not gonna lie. The screwing robot, or screwbot, knows just where to put them. The screws, that is. In fact, this process is so foolproof, they even let some idiot wander in off the streets to try it, and even he couldn't mess it up. I want you guys to watch this skill right here because this is impressive. This is how you do it. Look at me go. Okay, back to the people who actually know what they're doing. The next station is a manual keycap install. Remember how I said that keycaps are mounted to trays? Well, that's so that it's easier to map them to a keyboard layout. After the caps are put in place by a human, the robots again take over, applying uniform pressure to the keys in order to make sure everything is fastened down to the correct spec. Now that the keyboard is starting to look like something that you might see on a shelf, it's time to make sure it, works. This includes testing every key to make sure the strokes register correctly, and moving, jarring, and jostling the entire assembly around to see if anything comes flying off. After that, RGB functionality is put through its paces as well, because imagine how irate you'd be if Starry Sparkle didn't work. The next machine that gets a shot at the SK is an alignment tester, which does a visual inspection of the keyboard with a camera to make sure all the keys are in the right places, so you don't go to type will and end up saying but. Another inspection is up next on the agenda, where the keyboard is cleaned off of fingerprints and damaged or marred keycaps can be selectively and manually replaced as necessary. This is followed up by a final function test to make sure everything survived the entire assembly line. And then we're off to packaging. Since the SK line has a detachable USB cord, each finished product is paired up with one and then passed down the line to a worker who slides the whole thing into a velvet bag. The rest of the packaging is fairly simple, and the keyboard, instruction booklet, and power cord is placed into a black cardboard box and then inserted into a colorful sleeve. We were also privileged enough to see the entire line swapped over to assembling Cooler Master's new flagship gaming keyboard, the MK850. This is the product with aim pad built in that I reviewed on the channel, and because of its complicated internals, the assembly process was a little different. I won't run you through all of it because it was largely the same, but it did include multiple QCs that incorporated pressure testing the aim pad buttons themselves. Then it was time to move over to mouse production, where we started with a relatively small CNC that was carving out a piece of steel to be used as tooling for a mouse. Cooler Master showed us several different tooling pieces inside of this workshop, some of which unfortunately we weren't allowed to film, but each new mouse design needs its own tooling, similar to how cases are made. These tools will head off either to stamping or to injection molding, and then they'll make their way back to the assembly line. The internal PCB is designed in-house in that engineering room that we looked at earlier, and then outsourced for production. It then heads back here, where the factory produces about 2,300 mice per 10-hour workday. This particular factory, in addition to working with Cooler Master and producing 10 of their mouse designs, also partners with other large peripheral manufacturers, which again, unfortunately, we can't talk about as it is confidential information. When the mouse assembly line is up and running at full speed, they will often reach their production goal in the middle of a day and have to switch over the production line to another product entirely. Doing so takes about 2 hours and requires not only the gathering of completely different mouse components, but also swapping over the build stations, screws, QC checkpoints, and small placards above each technician that tells them what they need to be doing. Speaking of QC, or quality control, as with every other product we've looked at from Cooler Master on these factory tours, QC checkpoints come early and often in this process. Failure rate with mice is actually higher than on other products and can range between 2 and 5% depending on model. Obviously, the more complicated the assembly process and the newer the product, the higher the failure rate will be. If a mouse is found to be defective, as with the case factory, there is a repair station with a technician standing by to try to fix the problem. It will then go back to QC to verify that all systems are nominal. The last part of our tour was inside the large product torture test area. It was in here that Cooler Master proudly showed off their new testing station for ESD, or electrostatic discharge. The ESD gun that you see can put an electrical current up to 15,000 volts through anything it touches, or at least this is the highest amount of voltage that I could egg the technician on to pump through this SK650 keyboard. I was lobbying for him to go higher so I could have some exclusive footage of something blowing up, but at 15,000 volts the keyboard was still performing perfectly, but the monitor on the desk was flashing and flickering badly, so we capped it there. Plus, he actually said he had never gone this high before and was a little scared. Sorry, dude. The rest of the testing was for physical abuse rather than resistance to lightning strikes. There were several stations for testing mouse button longevity, where robots repeatedly click buttons until some predetermined threshold is reached, a number usually in the millions. The mouse is then retested for degradation and retained functionality, allowing Cooling Master to validate the lifespan claims of companies like Omron, which will provide a rating on their components. The same is done for keyboard switches, and for Cherry products the number of presses here is actually 50 million. You can see all the little prongs in the machine pressing various keys of different shapes and sizes to collect proper testing data. But that's it for this video, guys. I want to give a big thank you to Cooling Master for arranging these factory tours for us as well as for Gamers Nexus, and if you want more in-depth coverage on individual processes, be sure to go check them out as well. Thanks for watching, everybody, and I will see you in the next video.